In this lesson, we are going to solve this question I have on the screen. The question says a 80 kilogram block rests on a horizontal plane as shown. Determine the magnitude of the force P required to give the block an acceleration of 3 meters per second squared to the right if the kinetic coefficient of friction between the block and the plane is 0.3. So we have to determine the force P here, okay, which is causing the block to accelerate 3 meters per second to the right, okay, horizontally. Okay, so let's look at how you're going to do this. This is a kinetics question because it deals with the study of forces that causes the motion of what objects. So in this case, you have to find the force that is causing this block here to move. Okay, so this is kinetics. Okay, so now let's look at how you're going to solve this question. To solve this question, since we are dealing with forces, okay, we are going to draw a free body diagram for this system here and then indicate the forces that will be acting on the block. So I'll go ahead and then draw the free body diagram. Okay, so this is my free body diagram that I have here. Okay, so I have indicated all the forces that will be acting on the block. Okay, I have the weight force, I have the normal reaction, and then I have the frictional force here, and then I have the force that is causing the body to move at an acceleration of 3 meters per second square, which is the force P. So this is my free body diagram that I have here. So all we want to do is to find the value for this P here. Okay, all we want to do is to find the value for this P here. So let's look at how you are going to do this. So to find the value of P, you know that you have to sum all the forces in the X and then all the forces in the Y direction. So that's what you are going to do here. So let's go ahead. Okay, so looking at the force P here, it is at an angle of 20 degrees to the horizontal. Okay, so what that means is that it will have X and then Y component. So we will have to find this component. So looking at this, I'm going to have the X here and I'm going to have the Y here. Okay, and the Y will be moving downwards. Okay, the Y will be moving downwards because of the direction of force P, and then the X will be moving in this direction. Okay, so in that case, for the X component, okay, that's when I take the cosine of the angle 20, that will be cosine of 20 degrees. That because the adjacent, which will be what? The px over hypotenuse P. So that gives us the px to be equal to what? P cos 20 degrees, and then the y component py will be equal to P sine 20 degrees, but it is pointing down, so it will be what? Negative. So this will be the x and y component of the force P. So when we are summing all the forces in the x and then the y direction separately, we have to use each of the components depending on the direction. Okay, so now let's consider some of the forces that are acting on the body in the y direction. Okay, so you have what? Some of forces in the y direction to be equal to what? Mass times what? Acceleration in the y direction. Okay, so what is happening is that from Newton's second law of motion, it says that the net force on a body is equal to the product of what? The mass of the body and what? Its acceleration. Okay, so that's what Newton's second law of motion is saying. So that's what we are basically applying here. Okay, so that's what we are basically applying here. So when you consider the forces in the y direction, you are going to have weight, okay, which is moving downwards, and then normal reaction, which is moving upwards. Okay, so that will be r minus what? The weight, and then apart from that we have the py also, and that's also pointing downwards. So that what? Minus what? Py. So all this will be equal to what? Mass times what? Acceleration in the y direction. Okay, so I want to fill up some space so that we continue. Okay, so now we know the value of what? Py to be what? P sine 20 degrees. So in that case, you are going to have r minus what? The weight. Weight is mass times what? Acceleration due to gravity. Okay, so that what? 80 times 9.81. right, minus what, py, which is what, p sine 20 degrees. Okay, so this will be equal to what, mass times acceleration. We know the mass of the block, but there's no acceleration in the vertical direction, which means that the body is not moving upwards or downwards. It is rather moving what, horizontally. So there's no motion vertically. So in that case, acceleration will be what, 0. So that what, the mass 80 times what, acceleration 0, and that will make that side to be equal to what, 0. So I'll write 0 here. So let's simplify this. So I'm going to have r minus 80 times 9.81. That'll give me a value of what, 784.8. Okay, minus p sine 20 degrees. So this should be equal to 0. Then this should be my equation 1. So you're going to do the same for the sum of forces in the x direction also. So let's go ahead and then do it. Okay, let's take note of this equation here. Okay, so now you're going to consider sum of forces in the x direction. Okay, so that will be sum of forces in the x direction should be equal to what, mass times the acceleration in the x direction. So now for the sum of forces in the x direction, you're going to have px. Okay, you're going to have px minus the frictional force, okay, which is coefficient of friction times the normal. Okay, and then you're also going to have it be equated to what, mass times what, acceleration in the x-axis direction. Okay, so the only forces acting in the y direction is px and then the frictional force. Okay, so to be equated to the product of the mass and then acceleration of the block in the x direction. So all you have to do is to substitute the known expressions here. Okay, so we know that px equals what, p cosine of what, 20 degrees, right? Okay, minus what, minus the coefficient of friction times r, and we know coefficient of friction to be 0.3, so that will be minus 0.3 r. Okay, and then this should be equal to what, mass times acceleration. We know the mass to be 80 and then acceleration to what, 3 meters per second, so that will be times 3. So let me write this again. Okay, so now let's simplify this. So we are going to have p cos, you're going to have p cos 20 degrees minus 0.3 r equals 80 times 3. So this will be equal to 240. So this will be my equation 2. Okay, so these are the two equations that you have, and then you've been asked to find p. Okay, but you have two unknowns in this equation 1 and equation 2, so you just have to solve them simultaneously to get our answer. So let's go ahead and then do this. Okay, so I'll write down the two equations here. Okay, for equation 1, I have r minus 7. Okay, let me write this as r minus p sine 20 degrees equals 784.8. This is equation 1. Okay, and then for equation 2, I'm going to have minus 0.3 r, okay, plus p cosine of 20 degrees, and then this will be equal to what, 240. This is what, equation 2. So let's solve these two equations simultaneously and then see the answers that you are going to get. Okay, so I'm going to use the calculator to do my simultaneous equation here. So let's look at that. So to do this, you can press the mode key on the calculator, then choose option 5. Then from here you choose the first option. So for the equation 1, the coefficient of R is 1, okay, and then the coefficient of P is what, sine 20 degrees, and then all this will be equal to 784.8. Let's do same for equation 2 also. We'll have minus 0.3 as the coefficient of R, and then cos 20 for the coefficient of P, and then this should be equal to 240. So solving this simultaneously, I'm going to have R to be equal to 628.8 Newton, okay, and then I will have P to be equal to 456.15 Newton. So this is the force that we are looking for. So this is how to solve this kind of question, okay, which is what, kinetics question. So you just have to focus on the forces and then look at the direction where the block is moving, and then draw a free body diagram and then solve this question. Thank you very much for watching this video.